Hello everyone, this is Himanshu Chandra from Adhyayan IT Solutions. Welcome to the demo lecture for programming in C. The topic we are going to cover today is recursion. For the purpose of a demo lecture, I could very well have covered a very simple topic like for loop, while loop, variables, etc. But the reason I am covering a more complex topic like recursion is to give you the confidence that you do not need to be very good in programming before you join our classes, or have a programming background for that matter, to understand the more complicated topics which are present in C. Recursion is something not many people are comfortable with. I'll show you how to write a recursive program. I'm going to assume a few basics concepts are already known to you, like variables, integers, strings, etc. Even if you do not know them, don't worry. Just try to understand what recursion actually means and see if you are able to understand that. The reason I am asking you to concentrate on the logic rather than the code is, even if you are learning C or C++ or Java, .NET, any programming language, when you start writing complicated programs, sooner or later you will have to write recursive programs. At that point of time, it really does not matter what the syntax is. If you do not get the logic, you do not catch the logic of how to design that program, it just doesn't matter what programming language it is. The structure remains the same. The way you call a function, the way you write a variable might change, but the actual content which goes inside the function, inside the program, always remains the same. So let's concentrate on that. For programming in C, I am going to use the CodeLite editor. You can find it over the net. Just Google for CodeLite and you will be able to download it. It's an open source tool which compiles and runs C and C++ programs. If you have any other compiler like Borland C++ or Linux, that's fine. I chose this. It works well on Windows. So let's create a new project. I'm going to create a new simple executable C program. So CodeLite prepares the basic structure for us. This is already generated by CodeLite. Those who have a little background in C will realize that this is the header file which you need to include in a program, and this is the main function which actually C compiler executes. If I run this, you see hello world that is outputted on the screen. You can build a program in CodeLite from here, build project. The shortcut key is F7, or you can run it by using Control F5. Printf means to write something on the screen. Print it. You write printf, and then within parentheses, within quotes, you just write whatever you want to write it. \n, this actually means after writing the string, I want a new line character. This is like pressing enter. So, if you read the theory of recursion, what you will read is a function calling itself is a recursive function. Now obviously I need to tell you what a function is, so I'll give you a very simple and small example of what a function is. Those who already know this may want to skip the video a few minutes so that they are directly at the portion where I explain recursive functions. Suppose I wanted to write this somewhere else. I should have gone outside the main function. I could have written anything here. Void. I'll explain what the return types are later. You need not be bothered about that for the time being. Name of a function, my function, and I could have written this here. Here what I need to do is call my function. I save this. I'll run this now. So this runs and prints hello world for you. So function is nothing but something which you want to do outside of the main function. You can create your own function and call that. This means calling of a function. This is a function body. This is how you comment in C. Multiple line comments are written in this way. So as I said, I am assuming that you know the basics of what a function is, how to call a function, a very simple portion of C. And now we are going to cover something recursively. Let's suppose somebody has asked me to print the sum of first 20 numbers recursively. So I have a variable int n is equal to 20. What I am expected to do is give the sum of 1 plus 2 plus 3 plus 4 plus 5 till 20. But I have to do this recursively. Now pay very close attention here. How does recursion work? Most of the books would explain you that there has to be an exit condition, there has to be a line where you call the function once again, how the stack push and pop operations are done, and how the values and variables are pushed onto the stack and then later popped off from the stack. All that theoretical portion is very good, but that does not really help you write that program. You need to think in a different way when you are writing a recursive program. Let's concentrate on that and see what that thinking process is. Whatever courses you enroll for here at Adhyayan, be it C, C++, data structures or Java, what we concentrate is not simply on syntax, because that is something you can easily learn after a bit of practice, and there are lots and lots of materials over the net and hard copies of books where you can find the syntax. The problem lies when you try to create a new program and you do not know what the logic behind that should be. This is where we explain how to think about writing a program. That's the most important part. So let's see. Recursive program. Whenever somebody asks you to write a recursive function, first thing which you will do is you will create a function which returns you the final answer. In this case it is an integer. The sum of 1 plus 2 plus 3 till 20 will be an integer. You will return that value. X is equal to my function. You will pass the value of n here. The changes I am making are all related to syntax. Don't get bothered by them very much. In due time you will understand what is to be written where, but try to understand the logic so that you can at least write the pseudo code or think of the logic in your mind. See, whenever somebody says do this recursively, the first thing which I should think about is how can I do this by doing the least amount of work. A recursive program is a lazy man's program. Whenever somebody asks me, Himanshu, can you please tell me the sum of first 20 numbers? I'll tell him, can you tell me the sum of first 19 numbers? And then I'll add 20 and tell you the answer. So the first thing which comes to my mind is I'll have to search for some junior of mine to whom I can delegate this work. The moment I get this job from my manager to give the sum of first 20 numbers, I'll search for my junior, ask him, can you please tell me the sum of first 19 numbers? He'll give me the answer. I'll add 20 to it and give my boss the answer. I do not want to do much work here. I am not bothered how my junior finds the sum of first 19 numbers. That's his headache. My junior thinks I have got a new assignment and I have absolutely no idea how the sum of first 19 numbers is calculated. He'll search for a junior of his and ask him, how do you calculate, do you know the sum of first 18 numbers? How do you calculate that? Don't tell me that. I'm not really bothered about that. Just tell me the sum of first 18 numbers. Once he gets that answer, he'll add 19 to it and tell me what is the sum of first 19 numbers. So always write a recursive function. The first step which you should do is think in these terms and write that line. A bottom-up approach of sorts is required while writing a recursive function. You write the last line of code first. You are going to return your boss the actual number you had been asked, the sum of first 20 numbers. So you will add 20 to the sum of first 19 numbers. So what you are doing here is, when you had created this function, I'll change the name, returns sum. You had created this function with a view that this function will give you the sum of n numbers. How that works internally, you had no idea while creating this function. You are not even bothered about it. You just want a function which returns a sum. So you wrote that function. All it takes as a parameter is how many numbers do I need to sum up. You wrote this for that function. Just think that there is a magic box inside this function and it calculates it for you. You do not need to bother with writing the code for that. Then you realized you can ask somebody else to do the same function for you with lesser number of numbers and then add 20 to that. Okay. What is happening here is you are calling that function once again. Now, my junior does this, his junior does this, his junior does this. They all search for a junior, so on and so forth, and they all tell them, you tell me the sum of first 15 numbers, then 14 numbers, then 13 numbers, 12, 11, 10, 9, so on and so forth. How long can this continue? Can this go indefinitely? No. At the end, suppose there's a junior who has got the job to find the sum of first 2 numbers. He'll search for a junior of his and tell him, give me the sum of first 1 numbers and I'll add 2 to it and tell my boss. Now this last junior who has got the job of finding the sum of first 1 number should know in absolute terms that the sum of first 1 number is equal to 1. He cannot delegate this job to somebody else. He cannot pass this on. If he does not know the absolute answer to this question, what is the sum of first 1 number, there is no way this problem can be solved. He should know that answer. That is the last limiting or the exiting condition. The smallest piece of problem which is possible, which has to be solved in an absolute term. So, you write here, this is how you write an exit condition for a recursive function. If n is equal to 1, then you have to give the answer now. Return 1. This is the sum, right? However, if n is greater than 1, then you do this, whatever you had written. Okay? 0 errors and 0 warnings. Now we'll run this. You get the output as 210. I believe that is right. The sum of first 20 numbers is 210. You have not written any for loop, you have not written any logic how to actually calculate those through a for loop. All you have thought about is how to do this recursively. We'll do another example so that it is much more clearer. Something on similar lines. In fact, we'll do 2 more examples. 2 or 3. Let's see. Create a new project. So here is a new program. Let's suppose somebody has asked me, give me the sum of first 5 odd numbers, or give me the sum of odd numbers till 100. Give me the sum of odd numbers till 15. Let's suppose that function name is sum odd numbers. It takes a parameter of integer type. What we'll write here is int x and n. N is equal to, say, 10. Give me the sum of odd numbers till 10. So what I want is 1 plus 3 plus 5 plus 7 plus 9. Okay? So the user input will always be an odd number. I am taking a very simple case here. So user will always give an odd number. You have to find the sum of 1 till that odd number, of only the odd numbers. I'll create a function, sum odd numbers, and I'll call that x is equal to sum of odd numbers with n. And then I'll print whatever the answer comes. Then we create the function. Once again, think now, if somebody has told me, give me the sum 1 plus 3 plus 5 plus 7 plus 9. The first thing which should come into my mind is, give me the sum of 1 plus 3 plus 5 plus 7. Then all I'll do is add 9 to it and give the answer. So that is what I write. I'll return n plus the sum of one plus 3 plus 5 plus 7. Sum of odd numbers till 7. Right? I'll add 9 to the sum of odd numbers till 7. So n minus 2. How long can this go on? Till n becomes 1. If n is equal to 1, you'll have to tell the sum is 1. Let's run this. This is your sum. 1 plus 3 plus 5 plus 7 plus 9. I believe that is right. So now, let's take a look at another program, Fibonacci series. I believe this is a program which is quite recurring in everybody's syllabus, question papers, interviews, etc. Most of us simply try to memorize what the program is, how to write that, and simply write that in our exams without understanding what it really is. Let's apply the logic we have learned just now and see how Fibonacci series recursive program works. Let's create a function FiboSum we'll call this function and this is the function itself. This is the basic body of it. Now, I'll quickly refresh everybody's memory what a Fibonacci series is. This is a Fibonacci series. What happens is the first two numbers, they are absolute. The Fibonacci series can start with a 0 or a 1. I am going to start it with a 1. First two numbers are 1 and 1, or you can start with a 0 and a 1. This would be better, then it will be absolutely perfect. So it starts with a 0 and a 1. The next number is the sum of the previous two numbers. 0 plus 1 is 1. Then 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 2 is 5. 5 plus 3 is 8. 8 plus 5 is 13, and 13 plus 8 is 21. This can continue till infinity. Now the question which comes is, you will be given a number, say 5, and you have to tell what number appears at position 5 in a Fibonacci series. So 1, 2, 3, 4, 5. You have to give the answer that at the fifth position, the number in the Fibonacci series is 3. So, user in the form of n will give you the position number. So, n is equal to 5. This is the position number. I'll change the name of the variable so that it is much more clear. This is position. And you have to return the sum. Now, let's think about the logic here. If somebody tells me, give me the Fibonacci series number at position 5, I'll ask him, can you give me the Fibonacci series numbers at position 3 and 4? If you give me that, I'll simply add them and give you the answer. For example, this is what I was asked. I'll ask my junior, give me the values at position number 3 and position number 4. He'll give me the answers. I'll simply add them up and return the answer to my boss. So let's write that. What is the answer I'm going to return to my boss? The sum of position number 3 and position number 4. So, if 5 was asked from me, 5 minus 2 and 5 minus 1. Position 3 and position 4. Those are the Fibonacci answers I want from my junior. So I'll ask him the sum of this and this. I'll add them up and return the answer. My junior initially didn't know what I was going to do with the answers. I just asked him, give me the Fibonacci number at position 3 and position 4, because I was asked for the answer at position number 5. He gave me position number 4 and position number 3. I added them up. That is all I did. That was logic from my side. I added them up and returned the answer to my boss. I did not care how my junior is going to arrive at the answer of what is there at position number 3 and 4. That is his headache. I am not bothered by that. How long can this go? Can my junior tell his junior he was asked position number 4 and 3? Can he tell somebody else, okay, for position number 4, can you give me the answers of position number 2 and 3? And for position number 3, can you give me the answers of position number 1 and 2? He can delegate that work to somebody else. It's very much possible. But how long can this go on? If the position number is 1 or position is 2, you should know that at the first two positions the answers are 0 and 1. The first number in a Fibonacci series is always 0 and the second number in a Fibonacci series is always 1. You need to know that in absolute terms. From there on, you can easily calculate. The third one is sum of first two. The fourth one is sum of previous two, so on and so forth. But if you do not know what the first and second number is, there is no way you can solve this problem. So that becomes your exit condition. You write, if position is equal to 1, then you have to return the answer as 0, because the number at position 1 is 0. Else, if position is equal to 2, then you have to return the answer 1. If somebody asks what is the Fibonacci number at position 2, you have to return 1. Otherwise, you do not need to do anything. You just need to delegate the work to your junior in this way. And then apply the logic that whatever answer you received, you simply did something with that very small amount of work, which in this case is adding those numbers and replying the answer to your boss. This is all you did. Let's save this and then we run this. 3 is the answer. Let's check if that is correct. At position number 5, 1, 2, 3, 4, 5, 3 is the answer. 6, 7, 8, 9. Let's check if this is running correctly. Do this 9, save this, build it, 0 errors and 0 warnings, and then run this. 21. So your program is running correctly. So that is all we'll cover as part of the demo video. There are a lot of variations in recursions which we can cover, but the basic logic remains the same. Obviously, I cannot cover all those variations and examples as part of a demo video, but the basic essence and the logic remains the same. You can download the sample code files used here from the links given below. If you have any doubts, you can contact me through email or call me up on my phone. The details are here. There is a direct link for this video if you want to download it. If you want to know about the upcoming batches, the schedules, etc., the URL is given here, or you can directly call me up. Hope you like this video. Have a good day.